Hello and welcome back to the Envisiontech podcast. This time I'm going to be talking about the basics of programming and how things like scrolling on Instagram work. As I mentioned, this episode is going to focus on how different things work in programming. But don't worry, it's going to be a very easy to understand episode, and I'm going to try my best to not involve too much actual technical jargon, if you will. So the goal of this episode is to kind of make it so that you can understand how things that you use every day work a little bit better, and a little bit of how programming actually works as well. In episode 7 of the podcast, I talked about computer hardware, and then in episode 8, I talked about a little bit on how programming actually works. So in this episode, I thought it'd be good to take a little bit more of a look at programming. So as I mentioned before, well, code or a program is essentially a set of instructions for a computer in a language that computers understand. It's like giving instructions to somebody that you know, like, oh, hey, take the groceries out of the bags, put them in the fridge, make sure you close the fridge door, etc. Obviously, with computers, though, you need to be really specific. As I said in the previous episode, you can't be general. So you would need to tell it, oh yeah, open the bag, take out the butter, open the fridge door, put the butter on shelf number 2 on the left, etc. You can't give computers general instructions. I did also mention previously that there are different types of programming languages, and this is true, but there are also programming languages that have different functions. So there are more general purpose programming languages, web development languages, and there's quite a few others. So to give you an example, a language that you see a lot on websites is JavaScript. Now, JavaScript is made to run in your browser, so in Chrome, Safari, Firefox, Edge, whatever it is that you use. Whereas there's a lower level language called C, and there's another one called C++, and those are used a lot for things like self-driving cars, or for writing code that will actually just run on a computer. And a lot of games are written in C++ because C++ is faster than JavaScript as well. And along with that, there are variables, which variables are kind of like boxes, you can think of them. So you'll say, oh, here's a box, and we're going to put somebody's name in there, right? So the computer will have a little box called name, and in there it would have Paul, for example. Now, computers can have different kinds of variables. So that one that I just mentioned, where the box would have somebody's name in it, is called a string, right? And that is, as the name kind of implies, a string. So it's a string of characters. And there are also data types where you can store just individual characters, or numbers, or dates, or even lists of these things. So it's really important, though, that if I have a box called age and the computer is expecting a number, I have to put a number in there. If I try and put something that's not a number, then it can cause big problems, especially depending on which programming language that you're using. So just to give a few more examples of actual real-life scenarios where variables are used. So if you go to a website, and let's say it's Amazon, and on there it has a product rating. So it might be 4.6 stars, right? So that's what we call a floating point number. So the reason why it's called that is because it has a decimal point. So it has numbers after the point, if you will. That's different than, for example, if the website just said 4 out of 5 stars and the website actually didn't check the decimal point. That's called an integer, and those are whole numbers. I said there are strings, which are things like words and sentences. There's booleans. So, for example, they might have a thing that checks if your email is verified, right? And that might be false. So those are true and false values. That's what a boolean is. It can either be true or false, And then when you actually verify your email, they'll change that to say true so that you can access whatever page it is on the website. I said there's also lists. Lists just let you keep multiple things, as well as the name says, in a list. So instead of having, name 1 equals Paul, name 2 equals Melissa, name 3 equals Jesse, etc., you would just have names, and then you could have, Paul, Melissa, Jesse, etc., inside of that list, which is really handy for something that we'll talk about later on, now in a few minutes. But that is essentially programming variables. They're just little boxes where you can keep pieces of information. Another way to think of programming is almost like a recipe, as if you were going to bake a cake. And recipes have instructions, right, that will lead you to an outcome. So sometimes in recipes, for example, it might say, oh yeah, preheat the oven for 10 minutes, right? So obviously you're going to say, okay, well, did I preheat the oven? Yeah, okay, I can put my cake in the oven. Oh no, I didn't, so I'm going to have to wait for 10 minutes and then I can put it in the oven. So programming has a way of doing this as well. These are what we call control flow statements. So the reason why they're called that is because they control the flow of the program. So for example, you have an if statement. So using the example that we have, it would be if oven, is preheated, then we put the cake in the oven. Else, wait for 10 minutes, and preheat the oven. So there's if and else, right? So if something is true, do this, else do this, right? But then you also have else if. So if you have, for example, 2 doors, right, in a room, and you want to say, okay, if, right door, do this, if left door, else tell them to pick a door. So in that scenario, if somebody picks the right door, this happens. If somebody picks the left door, this happens, else this happens. So that would be if, else, if, else. So an else if is essentially letting you chain together these decisions, because you could totally just say if, right door, if left door, if neither, right? And that might sound fine to you, but let's say somebody picks right door. The computer would still say if right door, if left door, if neither. But if we use these sort of blocks where we can chain them together and it says if right door, else if left door, else, neither, then the computer will stop once it reaches one that's true. So if somebody goes to that right door and they pick that, it would just say if right door, it would do what it's meant to do, and then it would ignore the other two. And now that might not sound like a big deal in a small program, but if you have, 100 different options and you have 1,000 different places where you are, checking these options, well then there's, turning 100,000 into 1,000, which can make a huge difference in how fast your program runs. The next thing that you might be asked to do in a recipe is to do something multiple times. For example, you might have to crack 4 eggs. So instead of writing, crack egg 1, crack egg 2, crack egg 3, crack egg 4, you can have this thing in programming called a loop. There are different kinds of loops in programming. The one that we're going to talk about right now is called a for loop. So this would be, where you are cracking those 4 eggs. So instead of saying, as I said, crack egg 1, crack egg 2, crack egg 3, crack egg 4, it would just be, 4 eggs to crack eggs, right? So the computer would start at egg number 1. It would say, okay, we need to crack 4 eggs. So, if we haven't cracked 4 eggs yet, then we're going to keep cracking eggs. So it's going to crack the first egg. Then it's going to say, okay, we're on egg number 2. So we still don't have 4 eggs. So we're going to crack that egg. and again for 3 and 4. And then once it gets to the fourth one, it's going to say, okay, well, we have cracked 4 eggs now, so we can stop cracking eggs. And this can also be used with lists. So instead of, for example, displaying somebody's name on the screen, so I would have to say, like, display Paul, display Melissa, display Jesse, display whatever, Dave, etc., etc., etc. You can just tell the program to display a list using a loop. So, as I mentioned earlier, you can have a list of names. So we could just say, for name in names, essentially. So while there are still names in that list, keep printing out the names. So instead of having 100 lines of code, if we have 100 names, we can just have 2, where it will just loop through that list and print them out. There are other kinds of loops, too, to be exact. One of them is called a do-while loop. So this might be where you're asking somebody for an email. So you're always going to want to ask them at least once for an email. That's why it's called a do-while loop, because it will do something and then it will keep doing it while something is true. So in that scenario, we would do something. So we would ask somebody for their email address, and we would keep doing it while that email address isn't valid. So we would keep asking them for their email until they enter a valid email that is in our database. And this means that essentially it can go forever, right? There are also while loops, which are different to do while loops, because they will only happen if that thing is true. So, for example, it might be like while oven is, less than 100 degrees, for example, in our recipe example. So in that case, every time it would check if the oven is less than 100 degrees, and if it is, we could say like wait 30 seconds, and then it would check again. It would say while oven is less than 100 degrees, and then it would wait 30 seconds, and that would repeat. And obviously if the oven is off, it's never going to reach that, but hopefully it is, so it will eventually reach 100 degrees, or at least be above 100 degrees, because that's another thing. In programming, we have kind of 4 main ways to compare things. So we can say while this equals this, so I can say like while name is equal to Paul, so that will check if the person's name is Paul, for example. We can check if something is less than something else, so we can say, if age is less than 18, so that will check obviously if somebody's a certain age. We can say greater than as well, and we can say not equal to. Now you can kind of combine some of these two, and you can also have multiple statements together. So you could see if somebody's under 18 or if they're over 65, for example, in programming, because you can kind of put these things together. So as I mentioned, do while loops will do something once, no matter what, and then they might keep doing it, whereas while loops might do something. They don't necessarily do it in the first place. So, also as I've mentioned before, programming languages are translated into something that a computer can understand. So in our recipe example, obviously if you spoke Spanish and the recipe was in English, you would need to translate it before you actually can read it. So this is done in 2 ways, as I mentioned before as well, but I didn't really explain the difference. So as I mentioned, some languages are compiled and some are interpreted. So a compiled language is taken, so the program that you write is taken, and then it is completely translated into machine code that the computer can run. So that's as if you sat down with the recipe and wrote it all out in Spanish, converting it from English. Whereas interpreted languages, it's only done line by line. So every time it's executing a line of code, it's translating it. So that's as if you read an instruction, you turned that into Spanish, went off, did that instruction, and then came back and translated the next one into Spanish. So it's two quite different approaches. It means that often the compiled languages are faster than the interpreted ones because the program can just be compiled into what's called an executable file. So you may have seen them, .exe files, and there's loads of different types. But so a language like C or Java is converted into that executable form, and it runs quite fast usually. Whereas something like Python, for example, that's an interpreted language. So you don't really have a Python executable file in the same way anyway. You just have a Python file. And when you run that Python file, then it runs it line by line. And it'll do that every time. There isn't a, faster version of that file like there is with if you're writing a lower level language, a lower level language like C. Now I want to talk about how specific things work. So give you a few examples of features that you might encounter every day and how exactly those work. So, for example, the first thing here is you open your phone app on your phone and you want to search for Jerry, for example, right? Because you have a contact called Jerry and you want to call Jerry. So you open your app, you click on the search box, which opens a keyboard. So that right there is a program running. So somewhere on your phone, it is listening, essentially is what we call it. It's called an event listener, and because it's listening for an event. So it's waiting for you to click on that box or the search button, depending. And when you do, it will open the text box if it's just a button, or if it's just a text box, it will just make your keyboard show up, right? And then every time you type in a letter, it says, okay, well, here's the letter J. So let's bring up all the contacts with the letter J in their name. So it'll go through your list of contacts and it will check if there's a J in the name of that contact, and if there is, then they will show up. And then when you do it with an E, so it'll see, okay, well, we're looking for a contact with JE in their name. So it will bring all those up, and then et cetera, until you get to Jerry. And then you should just have one contact left. But if you have multiple Jerrys that have different last names, for example, then obviously all of them will show up. So even that, when you click on a key on the keyboard, it's listening for that. So it's, let's say, the J key. It's saying, okay, well, you clicked on the J key, so you want the letter J to show up. So then it will put the letter J in that text box. And that's kind of how something like a search function works. It loops through, as I mentioned earlier, it loops through those different contact names and will check what letters are in them, essentially. And for the second example here, let's say that we're on Instagram. So there's a few things going on Instagram. So number one, it's listening for you to scroll. So when you swipe up, for example, to scroll down the page, or if you're on an actual computer, when you scroll the mouse wheel, So it's listening for that, and it says, okay, well, you swiped, so now we're going to move the page, and we're going to display the next post. And then the one that was there previously is no longer visible on the page, right? So that's the first event that's going on there. And then the next thing it'll do is you want to like a post. So you tap on the post or you tap on the like button, depending on the platform that you're on. And it will say, okay, well, currently this post had 56 likes. So we're going to increase that number to 57. So now we need to change the number that shows on the screen to 57. And we need to change the number that is actually in the database to 57 so that anybody else who is looking at this post can see that it now has 57 likes. So again, it's listening for you to tap. And then once you do, it's giving you some feedback. So again, it's those event listeners that I talked about earlier, which is really common across websites and apps. And that is how most things function. Some super common questions that people often have about programming are things like, is programming hard? So, I suppose the answer to that question is yes, programming is hard, but only because it requires a lot of practice and problem solving. Programming isn't really something that you can just sit down and do. You can't just sit down and write a program. You have to sit down and think, okay, what am I trying to do here? What is the problem that I'm trying to solve? Because that's what a lot of programming is. Somebody wants you to do something and you have to figure out how to do it. But you have to figure out how to do it in a way that the computer will understand, right? So it is hard, but it's not very hard in a sense if you're willing to put the time into it to learn. So this will also depend on the programming language that you're learning. A language like Python, for example, is written quite like English, whereas a language like C is not written like English really at all. There's a lot of extra brackets and a lot of extra words that you wouldn't expect in English. Whereas Python, if you read a Python script, as they're called, without knowing programming, it's quite likely that you might be able to figure out what's going on. Whereas if you read one in C, it's quite unlikely that you'd be able to figure it out, at least on your first go. So that is also important to consider when you're talking about learning programming, is what programming language do you want to learn? Because if you want to learn Python, Python makes learning programming a lot easier. But maybe you want to make a game, so maybe you don't want to use Python. So in that case, it is going to be harder. Another thing that I feel like people think is that in order to be able to program, you need to be really smart. And although, it's great that people think that, because then they think that I'm really smart, the truth is that you don't need to be a genius or super smart in order to be good at programming. You do need to be creative a lot of the time, and you need to enjoy solving problems. So, if you're very persistent, you like making things, and you enjoy solving problems, then programming is definitely for you. And that's what I love about it. I tell people all the time that programming is kind of like my art. So, especially because I can't see, I can still make things with programming. And that is one of the ways in which I really enjoy it. I do also love solving problems, but I really love being able to actually make something. And everybody who writes a program is going to write it differently. So how I might make something would be different to how you might make it, or how somebody else might make it. It's very common that if you ask, 100 different programmers to solve the same problem, you're going to get 100 different solutions. And another thing that I often hear that is coding for everybody, well, yes and no. So I think it is. Now, whether you want to put the time in to learn it or not, that is up to you. But it will also depend on what you want to do. So if you want to learn how to be a web developer, for example, that's much easier than learning how to program a self-driving car, for example. So I think programming can be for everybody, especially because of how, many different options there are. Like if you want to make a mobile game that you can play on your phone, or if you want to make a smart home device that will, listen for voice commands and do certain things, you can do all of those things with different programming languages. So I think there probably is a programming language out there for just about everybody at this point. Just to kind of recap here on what we've covered today. So we've actually learned a lot. We learned about programming variables. We learned about control statements like the if statement and different loops like the for, do while, and while loops. We learned about even the different types of variables as well, so strings, booleans, integers, etc. And we learned about how a user might input something into a box and how we might listen for that event. So as I mentioned, the event listeners, where they'll be listening out for you clicking or scrolling. And we also learned how those kind of integrate into features that you use every day, like scrolling on Instagram. If you're interested in learning more about programming, as I've mentioned before, I actually teach programming, but there are plenty of free online resources to learn programming. It's hard for me to recommend where you should start, because it really depends on what programming language you want to learn. But there's things like Free Code Camp, and there's loads of other websites where they have free coding tutorials, examples, or even courses. Even here on YouTube, there are plenty of good ones. So if you're interested in learning more, you can go ahead and check one of those out. If you have any questions about things that you want to know more about, feel free to ask me, whether it be in the comments of the video, or even you can message me directly or send me an email, and I'd be more than happy to help you out. So this has been another episode of the Envisiontech podcast. I've been your host, Paul Gagan, and yet again, thank you for listening, and I can't wait to talk to you all next time.